Hello and welcome to this first lecture on Introduction to Electrical Engineering. So, double E or electrical engineering basically comprises of two different phenomena. The energy aspect of double E and the other one, which is the information aspect. So when we talk about energy, basically we are talking about the generation, transmission, distribution, and utilization of electrical energy. And here we usually talk about high high amplitude of voltages and currents. On the other hand, when we talk about information, basically it has to deal with some type of communication, and we usually talk about low voltages and current. So voltages of the order of 1 volt and currents in milliamperes, while here for the energy aspect we might be talking about an 11 kV overhead line or currents in the order of amperes. Now, for information, the biggest utilizer of information is communication. So communication. And for any sort of communication to happen, we need some devices or circuits. So now we'll take a look what these terms actually mean, devices and circuits. So a device in double E context means a basic building block of an electrical circuit. Now, what is an electrical circuit? I will come to it later. A building block for a circuit could be a resistor, it could be a capacitor, it could be an inductor. So these are basically schematics of the various building blocks or devices. So it could be a diode. So what these devices actually are, we will study in detail in later lectures. But here I just want to give an introduction to the basic terminology used in electrical engineering. So we have devices and then we have circuits. So what is basically a circuit? Circuit is a meaningful interconnection of devices. So for example, I can put a resistor here and a capacitor here, but this doesn't comprise a circuit. In order to make a circuit out of it, I can have something like a resistor here connected to a capacitor, and then this is connected with an AC voltage at the input, VAC. So this is a resistor, this is a capacitor, and if I supply my input here, V in, and if I take my output from here, V naught, then this is a circuit of an RC filter. So this is a circuit because it is a meaningful interconnection of devices in order to achieve a certain goal, which is filtering. So this is an electrical circuit. Now we also come across the term system in electrical engineering. So what is a system? So system basically comprises of circuits. So circuits themselves are meaningful interconnection of devices, but a system comprises of circuits and devices which may or may not be electrical. So for instance, giving a speech, for example, so my sound voice, the microphone converts my sound into an electrical signal. So this, let's say, is a microphone. And then the loudspeaker system has an amplifier. So this is an amplifier. So amplifier is actually an electrical device. So it amplifies the electrical signal into another electrical signal. And then I also have a loudspeaker, which is again not an electrical device, it is a transducer. So a loudspeaker converts this electrical signal again into sound. So this right here, the complete interconnection of one electrical circuit, because an amplifier itself has many devices and together they become an electrical circuit. And then we have some other electromechanical devices in this case, because a microphone is not an electrical device, it is an electromechanical device. So this combination of microphone, amplifier and loudspeaker, which may or may not be electrical, it can be interface devices. So the next important term in EE is that of a model. So a model in EE is quite different from the meaning of this word if you search in an English dictionary. A model basically for EE is basically an electrical. It is an electrical circuit representation of a physical phenomenon. And then as a function of the frequency, if I plot V over I, this, let's say, I don't know what this device is, but if I measure the voltage and the current, let me change this from this resistor to, let's say, a black box. I don't know what it is. I just apply a voltage across it, which is varying in with frequency. So it's something like V cos omega t. And I plot the voltage that I measured divided by the current, and I get something like this. So you can see that for this region, the ratio of the voltage and the current which I measure across this device is constant. So this means it is a resistor. So this thing here is a model of this physical phenomena. For this region, where the ratio of voltage and current is increasing linearly with frequency, this is no longer a model for a resistive behavior. So what I need to do, I need to add an inductor next to this resistor to take into account for this increase in the voltage over current as a function of the frequency. For this region, when the plot is actually decreasing with frequency, this is capacitive behavior. So in order to account for it, I need to add a capacitor across this circuit. So this is a more detailed explanation of a model. So model is representing this physical phenomena which I can measure in the lab with a device which I don't know. So for my circuital analysis, I can have a model like this. In the next lecture, we will go into some further terminologies related to electrical voltage, current, power, energy, charge, etc. Some of the terms which are really the building block of electrical engineering. So thank you very much for your attention and see you in the next lecture.